Hello everyone. We are solving question number 45 of GATE 2018 chemical engineering paper, and the subject is process control and instrumentation. The question is, for a closed loop system, consider the following transfer functions: process transfer function GPS, controller transfer function GCS, measuring device GMS, and final control element GFS. And corresponding to each of this element of this closed loop, we have been given the transfer function as GPS, GCS, the measurement is GMS, and the final control element GF is 1. So the question is, the offset in the closed loop response due to a unit step change introduced in the set point of the output variable is dash. So in this question, for this given closed loop system, we have to find the offset in the output variable if we are introducing a unit step change. So to start with, let us draw a block diagram of this closed loop system. So here we are introducing a change in the set point, and we haven't been given any information about the disturbance. So we will take disturbance as 0. So if YSP is my set point, that will be my input. We'll go from here. Then first we will be having the controller transfer function, that is GC. After that will be followed by the final control element, that is GF is equal to 1. And at last we will be having the process transfer function, that is GP is equal to 2 upon 7s plus 1. And then we will be taking the output. Now again we will be having a feedback loop which will measure this output Y, and its transfer function is GM is equal to 1. That we will be adding it over here. Now if I have to write the transfer function corresponding to this entire closed loop system, we can write it as Ys upon YSP. So this upon this, so we will be going in this direction. So the numerator will be the multiplication of all these blocks GC, GF, and GP. This GC, GF, GP, and the numerator will be the multiplication of all the transfer functions in the feedback loop. That is basically all the transfer function in this loop. That is 1 plus GC, GF, GP, and GM. So we can replace the transfer function of this individual element and then simplify it. So let's just replace it. 2 into GF is final control element is 1. Then GP is 2 upon 7s plus 1 upon 1 plus 2 into 1 into 2 upon 7s plus 1 into GM is 1. That is, we can write this as 4 upon 7s plus 1 upon 7s plus 1 will go in the numerator. 7s plus 1 plus 4 upon 7s plus 1. That is, we can further simplify this as y of s and ysp of s is equal to, so this 7s plus 1 will get cancelled out and we'll be having 4 upon 7s plus 5. So we have this transfer function of this closed loop, and now we have been given a unit step change is introduced in the set point. And that is, we are having YSP of S as 1 upon S, and corresponding to that we will be having YS as 4 into 7S plus 5 into this YSP, that is 1 upon S. Now in this question we have to find the offset. So we define this offset as whatever the set point is minus the ultimate or the final value or the steady state value of the system, that is Y of infinity. So here we are introducing a step change in the set point, so that is YSP will be 1, and we have to find this Y infinity. So to find this y infinity, we can use the final value theorem that states limit s tends to 0. That is y of infinity will be given by limit s tends to 0, s into ys. So let's just replace this ys from over here. So we will be getting limit s tends to 0, s into 4 upon s plus 1 into 1 on s. So over here, no, over here we are having this 5, 4s plus 5. So this will get cancelled out and we will be having limit s tends to 0, 4 upon 7s plus 5. So this will be equal to 4 into 7 into 0 plus 5, that is 4 by 5 is equal to 0.8. That implies our offset for the system will be 1 minus of 0.8, that is 0.2. So the final answer, we can write the offset in the closed loop response due to unit step change introduced in the set point of the output variable will be 0.2.